Okay.
Hello and have a nice day to Dr. Johnson and fellow teammates. Today, in this video, we will present about turbojet engine system in aerospace. First of all, I will introduce my team member. The first presenter is
Okay, my name is Muhammad Najmi bin Huzaidi. My matric number is DB190115.
and me, Nurul Wahida team Mustakim, DB190170 and
Hello, my name is Muhammad Syakirin bin Azhar and my metric number is DB190089.
And my name is Amir Asri bin Abdul Mutalip. My metric number is DB190031.
So we will continue our presentation about turbojet engine in aerospace. The first presenter is Najmi.
Okay, thank you, Wahida. I would like to explain the first thing is about turbojet engine for the introduction. What is a turbojet engine? Okay, turbojet engine is engine that made of a turbine to change air compression in the engine. It's designed to produce a thrust from the air intake to the nozzle with high speed out. Okay, for the history of the turbojet engine, the first turbojet engine was built at Henkel HE 178, and it flown in Germany in 1939. And it has been devised some years early in England by Sir Frank Whiteley. And the first flight that using his engine did not take place until 1941. And during 1960, it came into a common use. Okay, for the system, for the turbojet engine, firstly, air come inside the engine from the intake at the front, and it will accelerate by a turbine from the operated fan. Okay, this system engine providing advantage in power and economy compared to ram engine. Ram engine, what is different between ram engine and turbojet engine? Ram engine not have a major move part in its engine, but for the turbojet engine, if major parts such as a big turbine to make a high speed air out the exhaust or the nozzle. For the turbojet engine system, 100% of the air in entering the intake of a turbojet engine goes through the engine core. Not 100% use the air that come inside the engine. Okay, it used or more useful for the high flight speed, subsonic and supersonic. But this engine is poor propulsive efficiency for at the lower speed, which means at the lower speed for the aircraft or for the jet, and it limiting their usefulness to mostly high speed aircraft. That's all for the introduction for the turbojet engine. I will let my friend to continue the presentation.
Now I will presenting the design of the turbojet engine. First of all, there has 8 important components, which is diffuser, compressor, pump, fuel injector, combustion shaft, turbine, and nozzle. In the design of turbojet engine have 2 sections, which is cool section and hot section. What is the function of diffuser? Firstly, it's to diffuse the air when the air is supplied. What is the function of compressor? To compress the air that will increase the temperature and also the pressure of the air. And then pump. What is the function of pump? The air will be pumped and supplied to the fuel from the compressor to provide the mixture of the air. Fuel injector is to ignite the mixture of the air and the fuel. Combustion, the complete burning of the air and fuel will occur at the constant heat, at the constant pressure heat. Shaft, the connector between the compressor and the turbine. Turbine is observing energy from the high speed air passing. Nozzle is release the exhaust gas to atmosphere and produce thrust to the push the plane forward. Okay, now I will explain the operational principle of the turbojet engine. There has 5 stage. This is first a tech stage. Second is pressure. Second is compressor stage. What is combustion stage? 3 combustion state. 4 is gas generation turbine state, and 5 is exhaust stage through nozzle. First, at A tech stage, we can see at the picture at the right side, we can see the arrow. The arrow is the air intake to the turbojet engine. When the air uh, onto the turbojet engine, it's very smooth air, and then it will make the compressor turning at the lower speed. It need to minimize the loss of the airflow into the jet engine, but at the supersonic speed, it need to slow the airflow below the Mach 1. At the compressor stage, the flow is directed onto Venus and then the spinning compressor plate, where progressively large increase in pressure are produced. That's mean when the large pressure is produced, the temperature is increased. The compressor is the series of the fan. When the air is passed through each compressor state, it get more compressed. Then after the air through the compressor stage, it will go to the combustion state. At this stage, the air will burning. The air will mixture with the fuel and start burning to produce the gas flow at the much higher temperature. This process is continuously when the fuel burn and the pressure increase quickly in confident region and on top of the piston when the flow will pass into the gas generator. At the fourth stage, which is gas generator turbine, the hot mixture of the fuel and air will leave the combustor and expand through the turbine. When the mixture through the turbine blade will rotate and also will expand the gas and accelerated it toward the nozzle. At the turbine will experience the high temperature gas. The material selected for the turbine should be the heat resistant. After gas generate the turbine rotated, it will go to exhaust state through the nozzle. When the gas through the turbine, the gas will expand to the exhaust nozzle that will produce the high velocity jet, which is thrust the jet to move forward. That's all from me, and we go to the next presenter.
Hello, I'm Syakirin. So I would like to continue the presentation with the given title relate to the turbojet engine system. I will explain about the working principle used by the turbojet engine system, which is the first conversation of mass. For introduction, we know that the conversation of mass is a fundamental principle in physics and chemistry that state that the total mass of a closed system remain constant over time, regardless of any physical or chemical change that may occur within the system. This principle is also known as the law of conservation of mass. For the point number 1, mass cannot be created or destroyed. According to the conservation of mass, mass cannot be created or destroyed. It can only be arranged, rearranged, or transformed into different forms. This means that in any physical or chemical process, the total mass of the reactant must be equal to the total mass of the product. For the point number of 2, closely relate to the concept of the conservation of energy. Closely relate to the concept of the conservation of energy as declared by the law of conservation of energy. Together, this principle form the foundation of the law of conservation of mass and energy, also known as the law of conservation of mass energy. For point number 3, the commonly applied in the analysis of fluid flow, whether it be in liquid or gas. The conservation of mass, we know that this principle is a fundamental concept in fluid mechanics and play a crucial role in understanding and predicting the behavior of fluid. We can see that there are formula conservation of mass. Rho 1 A1 V1 equal to Rho 2 A2 V2. Rho 1 and Rho 2 are the densities of the fluid at two different locations within the flow, and A1 and A2 are the cross-sectional area, as we know, of the flow at those two locations, and V1 V2 are the velocities of the fluid at those two locations. And for the second work principle of turbojet engine system is conservation of momentum. Uh, the second of the conservation of momentum is a fundamental for introduction, is a fundamental principle in physics that state that the total momentum of a closed system remain constant if no external force act on it. In other words, the momentum before an event or interaction is equal to the momentum after the event. The first point, we can see that momentum is a vector quantity defined as the product of an object's mass and velocity. In other words, the momentum before an event or interaction is equal to the momentum after the event. And we can see that the formula, we using formula momentum equal to mass multiplied with velocity. And the second point, for the second point, the conservation of momentum is a fundamental principle in the fluid mechanics, and it play a crucial in understanding and analyzing the behavior of fluid in various applications. And we can see that the point number 2, we are few example of how the conservation of momentum is applied in fluid mechanics. There are two: jet propulsion and fluid jet and nozzles. In jet propulsion, in the field of jet propulsion, such as aircraft or rocket engine, the conservation of momentum is essential. For the fluid jet and nozzle, the conservation of momentum is utilized to understand the predict the behavior of fluid jets and nozzle. For example, if application of the fire hose, water sprinkler, or jet injector. And for the last, the principle is based on the point number 3. The principle is based on Newton's third law of motion, F equal to ma. For the formula equation of conservation of momentum, m1 v1 plus m2 v2 equal to m1 v1 plus m2 v2. We can see that there are formula equation of momentum. M1 and M2, the masses of the object A and B respectively, V1 and V2 are the initial velocities of object A and B. Respectively, V1 and V2 are also the initial velocity, final velocity of object A and B respectively. That's all from me. Thank you. I proceed to the next presenter.
Hello, Assalamualaikum warahmatullahi wabarakatuh. And I will continue the present of the work principle in turbojet engine system. The third work principle in turbojet engine system is Bernoulli principle. Bernoulli principle is a fundamental concept in fluid dynamics that relates the speed of a fluid to its pressures. It states that as the speed of a fluid increases, the pressure exerted by the fluid decreases, and vice versa, assuming the fluid flow is steady and there is no energy loss due to friction or other factors. This higher pressure air is then directed into the next stage of the engine. As the air passes through the compressor blade, its velocity decreases and the pressure increases due to Bernoulli principle. The pressure at the nozzle exit is lower than the surrounding atmospheric pressure, creating a pressure nozzle exit lower than the surrounding atmospheric pressure, creating a pressure difference that generates the forward thrust needed to propel the aircraft. There are four stages in engine jet system. That is the engine inlet, often referred to as the intake or air intake. Fuel is introduced into the compressed air and it's ignited, creating a high temperature and high pressure gas mixture. A third is the compressed air is then directed into the compressor section of the engine. And the last is the nozzle is the final part of the turbojet engine where the exhaust gases exit. Fourth equation, Bernoulli equation is a fundamental equation in fluid dynamics that describes the conservation of energy for a fluid flowing in a steady, non-viscous, incompressible manner. Uh, P plus 1 over 2 V square plus P GH equal to constant, where P is the pressure of the fluid, rho is the density of the fluid, V is the velocity of the fluid, G is the acceleration of the fluid, H is the height above a reference point. For the last work principle in turbojet engine is a conservation of energy. The principle of conservation of energy applies to various systems, including jet turbo engine. A jet turbo engine is a type of a combustion engine that is commonly used in aircraft propulsion. Throughout this process, the conservation of energy is upheld. This kinetic energy is to drive the compressor blades, increasing the pressure and temperature of the air. In each step of the process, energy is conserved. The various form energy are converted and transferred, but the total amount of energy within the system remain constant. First is intake. Air is drawn into the engine throughout an intake system. Second is compression. The air is compressed by a series of rotating compressor blades. Third is combustion. Fuel is injected into the compressed air and it undergoes combustion in the combustion chamber. Fourth is expansion. The hot and high pressure gases resulting from the combustion expand rapidly, driving the turbine blades. Fifth is exhaust. The exhaust gases are expelled from the engine at high velocity, creating a forward thrust according to Newton's third law. There is six uh, kind of energy in turbojet engine. First is kinetic energy. Second is potential energy. Third is chemical energy. Fourth is heat energy, 5 is mechanical energy, and the last is thrust. For formula equation, there are simple formula that we can use to calculate the conservation of energy. There is the conservation of energy principle serve as a fundamental guiding principle to ensure that energy is accounted for any given system. PE final plus KE final plus W equal to PE initial plus KE initial. PE is equal to potential energy, KE is kinetic energy, W is for work. Okay, that's all for uh, my present, and I think this is the last topic that I will present cover in my presentation in our group. Okay, that's all for my group. Thank you and goodbye.